Hello. Welcome back. So, where we left off, it was like, start up Zoom. Drawn on my screen. Okay. Where do we leave off? Yeah, we had this program and yeah, we wanted to do like one run through it and see see what the values are after one run. So let's check it out. So let's start with these three values and see what happens. Yeah, let's start with like some other values. That's kind of like a weird value. Let's start with like 128. Nice like round power of 2. Because the only thing that's being bit shifted here is A. Like A is being bit shifted a lot. So yeah. So let's start with 128. And so let's say like the initial three values are A, B, and C. Let's go like 128, 0, and 0. And so let's do it. Let's do the computation now. So A bit shifted over by 3. So A being 128 is 2 to the 5th, 6th, 7th. 2 to the 7th. Let's forget this. 2 to the 0, 1, 2, 3, 4, 5, 6, 7. So actually, maybe that's an easy way to remember it. Like if you do like 10 to the 6th, that's just a 1 with 6 zeros. So if you do 2 to the 7th, that's just a 1 with 7 zeros. Oh my God. Holy, like, seems really obvious, but I like never made that connection. Okay, so we got 2 to the 7th. So let's do the first thing. So like A starts off as this. And so then we say that B is equal to this thing shifted over by 3. So like B is equal to 7 minus 3 is 4. So this thing with 4 zeros. And then we'll XOR it with 5. So 5 is 4 plus 1. Yeah. So XOR. So there's 3 things. So then we say that B is equal to 1, 1, 0, 1 like this. And then we'll shift A over by B. So we don't want B to be a huge value because we're just gonna zero out A. Wait, okay, so we're just doing that into C. So B is, what number is B right now? B is B is 0, 1, 2, 3. So this is 8 plus 4, which is 12, 13. B is 13 right now. So A would get shifted over like 13 things. So that clearly becomes 0. So basically like C gets zeroed out. And so now we do B exclusive or C. So this would just like keep B as it is, like untouched. It's kind of funny to think about giving this program to ChatGPT and just like tell me what this program does, but just having to work through it. So So C gets set to that. So B gets put in here, and then just like out of nowhere, like A just gets shifted over 3. Oh, it's like this exact same operation here, but A just gets shifted over 3, but it actually gets put back into A. So A becomes that value now, like this value up here, 1, 0, 0, 0. Now B gets exclusive ORed with 6. So is this right? Like B is just getting exclusive ORed with, okay, fine. We're just exclusive ORing it with like the literal 5 and the literal 6. All right, so B, so 1101 gets exclusive ORed with the literal value of 6. So it's just this. It's 4 plus 2, which is 6. So this is exclusive OR. So we got 1, 1. This becomes a 0, and this is 1. So now B is equal to 1011. And so now we do the out command. B gets shifted over 3 things. So basically like this gets chopped off, this gets chopped off, and this gets chopped off. So we just have a 1. So the screen gets output a 1. And then we jump back up to 0. Well, we check, okay, is A 0? No, A is not 0. So yeah, we jump back up to 0. So the initial values were this, and now let's read off the initial values. So it looks like what happened to A was A got shifted over 3, and that's the only thing that happened to A. Like that's the only like setting of A that happened. So A is 2 to the 3, which is just 8. Doing that new trick where I just like count the number of zeros, it's just 2 to that number. And then so B went from 0 to 1011. So this is 1 plus, so this is 8 plus 3. So this is 11. So B is 11 now. And C is 0. So what's jumping out now is like we can actually compute like from, we could basically compute what is like A prime, B prime, C prime from some function of A, B, and C. Like what are the different values of A, B, and C? So what is A prime? Like it looks like A prime just equals A shifted over 3. That's literally it. So is all of this extra stuff just irrelevant? Like we want to put out a program the length of 16, right? So do we just have to do 16 divided by 3 and like that's the answer? Is it just like A is just going to get crunched down to 0. So 16 divided by 3, it's 5. I guess the integer division thing, if it's just integer division, it'd be 5, but it's actually equal to 5 point something. So would A just have to be basically like 2 to the 6th? Because if A was, wait, I mean, A has to be a number big enough so you like chunk off 3, chunk off 3, chunk off 3, and you can do that 16 times. So it would be 16 times 3 then, which is equal to 16, which is equal to 32 times which is equal to like 32 plus 16, 48, right? So is it just 2 to the 48? Like, is that how do we submit this? What is the lowest initial value? Value seems too large. Well, actually, let's see. 2 to the 48, like what is that? It's just this number with 14 zeros. Let's just this thing times 10 to the 14th. Is it just this? I can't copy this. Yeah, it's not the right answer. It's too high. Okay. Why did this zoom in like crazy? So that had a chance of working out, but I don't know. Like if we let's like simplify it a little bit. So let's say, okay, so we have A, B, and C. So let's say we wanted to print out a program of just length like 4, I guess. Maybe 2. Maybe we just want to print out 2 things, like 2 things. And so let's say we put like A is equal to 1 with 3 zeros. It's like 2 to the third. So we would have this A shifted over 3 thing happen, and then that would give us a 1. And then by this point, A is not 0, so we would kind of come back over here. So then we would go around the thing again, and we would do A shifted over 3, and that would be a 0. So to get a program length 2, the minimum value was 2 to the third. To get a program length of 3, like, let's say it's 2 to the 6th. So it's 1, 2, 3, 4, 5, 6. So basically 1 pass through, we chop these off. And is this value 0? No. Is second pass through, is this value 0? No. Third pass through, is this value 0? Yes. So 2 to the 6th. So now a program of length 4, just following this, like 3, 6, 9, would it be 2 to the 9th? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first time through, 3, and we get something. Second pass through, we print out something, and then we chop this off. Well, we chop it off, we print it out, and then we say, do we have anything left? Yes. And now we go back around and then chop this off and print out the 4th thing. So following this through, it seems like we have 2 goes to 3. These are increasing by 3. So it's almost like 2 to the 3 times n. It's almost like that. But we have like 2 goes to like, basically like 2 should go to 1 in terms of n. 3 should go to 2. 4 should go to 3. So we basically have 3 times n minus 1. So to get a program length n, like 3 for instance, you need a number that is at least 2 to the 3 times 3 minus 1, which is 2 to the 3 times 2, which is 2 to the 6th. That checked out there. So if you want a program length of 16, you say it's 3 times 16 minus 1, 2 to the, which is equal 2 to the 15th. And yeah, let's, I don't think the number we just tried was 2 to the 15th, was it? We said 2 to the 48. Wait, why does this number seem way too low? How are we possibly going to get, oh, no. Shoot. Yeah, that's why it seems so low. It's because we didn't do 3 times. Okay, we got to do 2 to the 3 times 15, which is equal to 2 to the 45. What was this? 2 to the 48? All right, let's try 2 to the 45. Let's see. Why does this suck so bad for copying and pasting? The answer is too low. Okay, so maybe that was just like a lower bound on how low it could possibly be. Like, yeah, we know it's at least 2 to the 45. So I guess we can just stick that in our back pockets. Just say down here that A is at least 2 to the 45. We know that. So let's go back to what we were doing before with the values of A, B, and C, and let's see if we can get further with that. So A, B, and C. So yeah, A started off as 128, which is 2 to the 7th. So 2, 3. And then it got chopped off. Like these 3 got chopped off, and there's just 2 to the 4 left. So it went down to 16. Dang, should have copied these values here. Forgot what they were. I think C started off 0 and C like remained at 0. B started off at 0, and so B is the most complicated one out of them all, because so like B has like 1, 2, 3, 4 steps and is involved in the output. Like A only has like 1 assignment and C only has 1 assignment. But B is pretty complex. So let's see what's happening with B. So let's say like B2 is equal to A shifted over by 3, and then B3 is equal to B2 XORed with 5, and then B4 is B3 XORed with C, and then B5 is equal to B4 XORed with 6. And then B5 shifted over by 3 goes out to the screen. So A shifted over by 3 is 16, and then 16 XORed with 5. 16 was 1 to the 4, 1 to the 1, 2, 3, 4. There's 4 things. XOR with a 5. 2, 3, 4. 1, 2, 3, 4. Yeah, XORed with 5. So 1, 10101. It seems different than what we did last time, so I don't know. It seems kind of weird. 2 to the 0, 2 to the 1, plus 4, 2 to the 2, 2 to the 3, 2 to the 4, 16. So it looks like this is 21. And then B ended with C, XORed with C. This is just still going to be 21. And then XORed with 6. So we have 10101. Let's just do this. And let's XOR it with 6. So we want a 2 in there, and we want a 4. 1, 1, 0, 0, 1. This is 1 plus 2. No 4, no 8, but a 16. 18, 19. And then B modded over by 3 goes over there. So I don't know. B became 19. So yeah. I guess I feel like now that we kind of like understand just like the machinery of what's going on, I mean, it's still not clear to me intuitively to me what's happening to B. Like B is getting bigger here, but maybe it'll get smaller soon. A is just going to get chopped off by 3 every time. That's really straightforward. C. See, this is kind of unintuitive here. Like when you XOR something by 5, because you could increase it or you could decrease it. So I guess the only thing I know is like, yeah, C is just going to be A bit shifted over by the number in B. So if like B is big, then like C is just going to go to 0. So it's almost like, so I said, yeah, if B is big, then C is going to go to 0. If B is small, then C is going to be close to A or like big. So I will say that C is going to be inversely proportional to B. So we'll say that. So we'll say that if C is big, so if B is big, then C is small. If B is small, then C is big. Basically, if B is close to 0, how about we'll do it with logic. We'll just say like B being close to 0 implies that C is close to A, basically. So we know this relationship between C and B, I would say. So it's kind of like, but okay, why did this all start off? Because like we're trying to like characterize C a little bit and like kind of understand what happens to it. So we say if B is big, then C is going to be small. If B is small, then it's close to A. So, and then I don't even know like about B. I mean, we're just doing 3 XORs? We're doing 3 XORs? Dang, okay. 5 and 6. Okay, it's close to 5. If C was very close to 5, then we would just be swapping like B would basically become 5, and whatever value B was would just whatever get like go away, but B would get close to 5. Okay. Got kind of distracted by something. Should silence my phone. Oh yeah. So I thought the next idea would be to let's like figure out what values we need for the first value output to be 2. Like let's not forget about the iteration thing where we have to like output 16 numbers or whatever. But let's just see like what the settings for A, B, and C would have to be so that we get 2 as the first one. So I guess we can kind of work. This just seems like kind of crazy. So, all right, let's work backwards. So from this last step here. So in order for this very last step to be 2, it has to be the fact that like B5 shifted over by 3 is equal to 2. So basically we need like B5 to be equal to, well, we have like 1, 2, and then it basically has to be, yeah, basically whatever values we need here, 1, 2, 3, these can be any values whatsoever. These could be 1s, they could be 0, but they're going to be chopped off. So B5 basically needs to be this. So B5 needs to be this to get 2. And so in order for B5 to be that, what does B4 have to be? Needs to be, okay. I think I'm kind of running out of gas right now. So yeah, I guess the next step would be working backwards, and we'll see how we can do it. Yeah, dang, this problem's pretty intense. Well, I don't want to say intense. It's just, I don't know. It's just involved. This B thing is annoying. This like 3 exclusive ORs, because like exclusive ORs are just kind of my nemesis. Like they're just a very unintuitive, like discrete operation, which is kind of weird. Like I was doing this Geeks for Geeks problem, which was compute the H index, And that felt a little bit similar in like, it feels like a very discrete measure that is just not very intuitive. Like you can do out examples and you can see it, but it's still like, it's still not very intuitive. Because exclusive OR, it can either like increase your thing or it can decrease your thing. Maybe this would be a good chance to just get intuition on exclusive OR, honestly. Like, let me just experiment with it for a second and just see. Need some more chapstick. Just do it out some more and see if. So the thing where we exclusive OR something with itself, you know, if we have like 5, for instance, it's like for, is this 5? 1, 2, 4. Yeah, this is 5. So basically like 5 done with itself. Yeah, it's going to be 0. I feel like I don't really care about overall intuition with exclusive OR, but I do care about intuition with exclusive ORing with 5. So I have intuition when you like add something by 5, it just like goes up by 5. I know what happens when you subtract something by 5, it just like goes down by 5. I know what happens when you multiply something by 5. It goes up by like a factor of 5x. Becomes like 5x bigger. And I know what happens when you like divide something by 5. Actually a better way to kind of write it is it like you have like 1, 2, 3, 4, 5 kind of like versions of it, kind of like 5x it. And then if you divide something by 5, it kind of like gets shrunk by 5. It's like 1, 2, 3, 4, 5. It doesn't get subtracted by 5. Doesn't get like subtracted by 5 times that thing. It's like it like shrinks. It shrinks to a fifth of the size. It's like it like shrinks to a fifth of the size. No, you want to do the height. It shrinks to like a fifth of the size. Yeah, kind of like whatever. This thing like 5x would be this. So yeah, I have intuition for all these things, but like what does exclusive ORing something with 5 do? Like what is the intuition for that? It's like what is 5 in binary? Like 5 is this. So if you have a number that I guess just like ends in 5, right? So you have like 95. I mean, like the last 3 bits are going to be that. Wait, is that right? We could do some examples and we could see if that's actually true. So like 95 in binary, like what is 95 in binary? Yeah, the last 5 digits are not all 5. All right, let's ask ChatGPT and see what it says. Intuition for what happens when you exclusive or a number by 5. XOR basics, flip the bits. Like if I do 95 exclusive or 5, would it be 90 or 100 or something else? Is there a way?
Here is your reminder. DS.
Is there a way to predict or get a feel for whether it would increase or decrease, and by how much? Okay, I forgot about that. XOR just like flips the bits. No, it doesn't flip the bits. It only flips the bits if it's like a 1 and a 0. Yeah, whatever. General strategy. I know that you can mechanically do it out by hand, but that doesn't give me any intuition. I want to know I want to have some sense by just looking at a number, how much it will be affected by XORing with 5, like 85 or 2 or 55. Gut sense. So the magnitude of the change is always one of these values. 5 plus or minus 5 plus or minus 3. Wait, why would it be plus or minus 5 or plus or minus 3? Like, basically there can be 2 cases. So with 5, yeah, I mean, like, sort of like both of these values could be 1. So yeah, that would be plus 5. But it could also be the case that, Well, all those values could now go to 0. So you could do -5. Or you could, I don't know, those last few values could be like 100. And so this is the 1 and this is the 2, 4. So in this case, this would go, so we would lose the 4, but we would gain the 1. So it'd be -3. Or if we add 001, we would gain the 4, but we would lose the 1. So it'd be +3. Okay, interesting. So it's like the maximum value is 5, but that 5, like the value itself is very weird because you can't really, I mean, if we're just XORing with, 4, then only one thing could happen. We could either gain a 4 or we could lose a 4. But if we're XORing with 3, for instance, there's like different outcomes. We could, I mean, that's just like, it's these. So we could either like gain a 3, we could lose a 3, we could gain a 2, and so we could gain a 1, or we could lose a 2 and we could gain a 1, -1. I guess, and if we were XORing with 7, it would be kind of like different like that. But the most you could gain is 7, and the most you could lose is 7. And you could be somewhere in between. You're like XORing with 7. So you could either like gain a 7 or you could lose a 7, and you're like somewhere in this range. Hold on for a second. I gotta pop up this Zoom thing, see if anyone shows up. Running this event. Some office hours. Here, I'll stop the share. Probably gonna be the one day someone shows up. Okay, good for right now. Looks like this isn't being recorded, so I could just keep sharing this. Okay. So that's pretty interesting with XORing something. So we're XORing something by, X. It's basically like, yeah, just to get a shape for it, like you could either add X or you could subtract, you could add X or you could subtract X. And it really just depends on the value that you're XORing. And there's kind of like the distribution of outcomes you could do. It's more like the number of possible outcomes you could have increases as like the number of bits increases. You could have, they're all symmetric depending on how many you have. How do you even characterize the number of ones in a binary string? Like a binary string is equal to you know, x1 times 2 to the x plus x2. It's more like b1 plus, it's more like b0 times x to the 0 plus b1 x to the 1 plus, b whatever m x to the m. This actually doesn't, this is like an infinite sum. Those could all be 0, like going this way, but I don't know how you like would characterize this though. Yeah, whatever. So, but this is the key intuition here. I didn't realize. It's kind of interesting. Yeah, when you like take a number and you XOR it with x, it's almost like you're saying like, oh, it could either be like plus x, or it could be minus x. It's almost like n plus minus x like this. It's like plus and minus like together. So looking at this example then, so you're taking b and you're XORing it with 5. So you take like, start with b1. Say b1 is equal to a over 3. And you say basically like b2 is equal to b1 plus or minus 5. It's like we're just kind of like shifting it to the left or to the right 5 a little bit. And then we're saying b3 is equal to b2 like XORed with c. So now like we have b2 and we're either adding c to it or we're like subtracting c from it and we're like winding up in this range. And then finally we take b4 is equal to b3, basically like XOR 6. So we take b3 and we could like add 6 to it or subtract 6 from it, and we wind up in this range. So that's interesting intuition on the B operations, on the XORing operations. So you basically get a smaller version of A. You basically get, a smaller version of A. And then it like shifts a little bit by 5. And then it could shift a lot by C. Remember we said that C is inversely proportional to B. So if B is small, then B is large. Recall. So if B is like 0, then C could be big and like B could like really jump like by C or minus C. If B is like pretty close to 0, I would say. But if B is really big, if B is like all the way out here, then yeah, it's basically like not going to move at all. So it like barely moves, and maybe it moves a little bit more, and maybe it moves like even more. And here it could like really shift back up. All right, so that's cool that we have at least more intuition on that thing. Yeah, it doesn't seem like B is going to get swapped for 5 necessarily, because the only time B would get swapped for 5 is if I don't even know. I like a little, yeah. So, oh yeah. So, okay, yeah. Going back to just like recalling the thing, we were trying to work backwards. Remember? So it was like B1 is equal to A shifted over by 3. B2 is equal to B1 XORed with 5. B3 is equal to B2 XORed with C. B4 is equal to B3 XORed with XORed with 6. And then, we take B4, do it by 3, and that goes out to the screen. So recall we said B4 has to be 10 XXX like this. And then, so how do we get 4? Like, what does B3 have to be? B3 to get this. Well, that's convenient. 5 fits in these last 3 bits. So it doesn't matter. Like B3 can be anything. B3 can be 10. It doesn't matter, because like we're only going to affect these bits. So B3 can just be anything. And then so we say B2, what does B2 have to be to give this 3? We're doing B2 XORing with C. Well, yeah, now it gets kind of crazy, because B could be really big, and we just like zero out all these numbers by the XOR, and we have like a 10 XXX, kind of like that. It could, like, depending on what C could be, these could even be different. These could be different. This one's kind of weird. Okay, I feel like I've kind of made some progress on this. We'll see where we get with it next time. Yeah, this is kind of where it's at right now. So, all right. Thanks, guys, for tuning in. Hope you enjoyed. Peace. Peace.